Hi. So here we have a question about functions that are always increasing. And this is a little bit of a weird question because there's a nuance here, right? So for example, if I were to plot the square root of x, it would look something like this, which appears to always be increasing, and in fact it is. But we could do something a little tricky and just graph the negative square root of x, which would give us something that looks like that, which is clearly not always increasing. That doesn't feel like it counts because you could always, for any increasing function, just put a negative in front of it. And it would make it not always increasing. So we're not going to count stuff like that. Here, I'm just going to take the basic function of x for each type of these functions, and we'll discuss that. And you can use that to apply it to, if this is your homework or whatever this is, using your best judgment. So which functions are always increasing? So for linear, we have x. So y equals x. That graph looks like this, and it is, in fact, always increasing. So yes. Quadratic. In this case, we have y equals x squared, which looks, and it won't be exactly right, but the parent function looks something like this, which clearly it's decreasing everywhere less than 0. So no, the quadratic is not always increasing. Absolute value of x. Well, that's just the same as the linear x, except everything that was once negative is now positive. So really, all of this gets canceled out, and our actual graph looks like the letter V. So it looks like this, which clearly is decreasing at less than 0. Okay, the square root of x, as I showed before, looks like this, and it always increases. It doesn't actually flatten out like I made it look there. So yes. The cubic looks, it's x cubed in this case, and it looks like this. So yes, that is always increasing as well. Cube root, same thing. We have it increasing, goes through 0, flattens out, but it's still, I messed that up a little bit at the end there. But yep, the cube root is always increasing as well. Rational. So in this case, we have a rational function divided by a rational function, so 1 over x. And this one is not always increasing. In fact, it looks like it's pretty much going down the entire time. But it's not always increasing. So no on the rationals. Exponential, that's e to the x. That looks like this. And pretend I didn't draw it going down a little bit there. This is asymptotic, so it is always increasing. And logarithmic is just the inverse of this. And again, we do in fact have always increasing. So for the most part, most of these are always increasing. Quadratic is not, absolute value is not, and rational is not. Everything else, its parent function, so the simplest function you can make, or a simplest function you can make using each type, are always increasing. But again, be smart about how you apply it, because while x cubed is always increasing, negative x cubed is not. So use your best judgment to answer this. But this template and those reasons are a pretty fitting answer to the best way I could answer this. So there you go.